Now, in this video, we will going to discuss about how to solve on the projections of lines on the problem number 55. It is read as a line has its end capital A is 10 mm above HP and 15 mm in front of VP. The end B is 55 mm above HP and the line is inclined at 30 degrees to HP. The distance between the end projectors is 50 mm. Draw the projections of the line and determine the true length and its inclination with VP. So as he has given that the position of the end A is given and the end B, locus of end B in the front view he has given. So because end B is 55 mm above HP and the line is inclined at 30 degrees to HP. So he has given the true inclination with respect to HP. So since we have the locus directly in the front view, so you can directly get the true length. Once you get the true length in the front view and the distance between the end projectors is given, so naturally we are going to get the front view. So once the front view and true inclination with respect to HP is known, so we can easily find out the top view and its inclination. So how to find out that? We will see now. So first we will going to take up the end A. End A is 10 mm above HP and 15 mm in front of VP. So when you look from the front view, I can see the distance end A, which is 10 mm above HP. When it is projected, it will go projected onto the vertical plane, which will going to have small a dash and capital A here. So that distance is end A, 10 mm above HP and 15 mm in front of VP. So when you look from the top view, we can see the distance in front of VP, that is this distance. When it is projected, it will be projected onto the horizontal plane. You will going to get a small a. So this distance is end A, which is 15 mm in front of VP. The end B is 55 mm above HP. So when you look from the front view, I can see the distance end B, which is above HP by 55 mm. So when it is projected, you will going to get directly on the locus of B in the front view. So you got the locus of B. So with A as center, so he has given the line inclination with respect to HP. So he has given the true inclination of the line with respect to HP. So with capital A, which is in space, from here you measure an angle of 30 degree with respect to the horizontal. You draw a line so that it will going to cut the end B at a distance of 55 mm above HP. So you got the true length here. Once you get the true length, so when it is projected, it will be projected directly onto the vertical plane. So in other words, I am taking end A from A dash, you measure an angle of 30 degree and draw an inclined line so that it will going to cut the locus of B in the front view. So that you will going to get B1 dash and you mark this as locus of B. Then as we know that the distance between the end projectors is known. So from A, you measure a distance of 50 and draw a vertical projector in the front view so that it will going to cut the locus of B here. So you mark this point as B dash, then join A dash B dash with a dark line. So you got the front view. And this front view, and now in the top view also the end projector is extended to the horizontal plane. But now we need to find out, as we know that the true length is given in the front view, so obviously that line has to be parallel. So when you look from the top view, we can see that the end A is 15 mm in front of VP. Similarly, the end B1 is also in front of VP by 15 mm. So you have got small AB1 here. So but actually what happens is when you are projecting, so now we know that we have a one projector. So but here when you are rotating, how we will going to rotate? Now we have the capital AB1. So this is the true length. So in the top, it is in the front view, it is a true length, means obviously that line should be parallel. So we can see that AB1 is the one which will going to be here. AB1 is the one which will going to be parallel. So this length will going to be A is here and capital B1 should be here, because due to the clarity we have removed that. So obviously that distance will going to be the one which will be considering. But now what we will do with A as center, taking the radius of AB1, so you will going to rotate it. How we will going to rotate? With A as center, take AB1 as the radius, you rotate in space so that the B1 image which was here, it starts rotating here on the horizontal plane. Till where? Till to this end projector where you have been shown, so that this top view point will going to lie, or it will going to cut this end projector at this particular point. So you will going to get the top view. So once you get the top view, that means you will going to get capital A, B here, join A to B with a dark line in space. Now once you get this point B, you mark this point as small b, then join A to B with a dark line. So now we are going to get the locus of B in the top view. So we know the locus of B in the top view, and we have the locus of B in the front view, and we know this A dash B dash, which is already got. Now we need to find out the true length in the horizontal plane. So to find the true length in the horizontal plane, you have to make the line parallel to HP. So how to make that line parallel to HP? So now with A dash as center, taking the radius of A dash B dash, you rotate it and make it parallel. Once you do that, you will going to get, so that means when you are rotating this, what happens? With A as center, you're taking the radius of AB, you rotate it and make it parallel here. So once A is in front of A is above HP by 10 mm and B2 is also above HP by 10 mm. So when you are projecting this into the front view, you are going to get B2 dash, A dash, B2 dash is above HP by 10 mm. Then the line is parallel to HP. So obviously we can see that line also here in the space, it is parallel to HP. So you are getting the true length in HP. So when it is projected here, so you are going to get small AB2 is the line which is parallel to HP. So obviously that will be in true length. But how we can say in the horizontal plane, how you have to make it? So once you make it parallel, so you project this point till here, and then from here you draw a vertical projector so that it will going to cut the locus of B here, and this, then you mark this point as small b2, then join small ab2 with little bit thicker than the xy line. So this is how you will be able to find both the true length in the top view and also the true length in the front view. So we need to find out the true length in the and the true inclination with respect to VP. So you denote the symbol by name phi because it is the true inclination with respect to VP. So now we are going to try to solve the problem using the step by step. How? So first we are going to take up NDA above HP and in front of VP. So you're going to get this point. So once you get this point, we know that the other end point, which is 55 mm above HP, and then you know that it is the true inclination line, which is 30. So you're going to get 30 degrees. So you're going to get capital AB1. So when it is projected, you are going to get directly on A dash B1 dash. So that's what we have got here. So how to do it in orthographic projection? How are you going to analyze it? So what we do, so you take 10 mm above HP and 15 mm in front of VP. So you got A dash and A. So then from A dash you draw, then you have XY, from XY line you measure 55 mm and draw the locus line, which is locus of B. Through A dash you measure an angle of 30 degree with respect to the horizontal and then draw an inclined line so that it will going to cut this locus here. So you're going to get this as B1 dash. As we know that it is capital A and capital B because it is a true inclination line. So obviously this length will going to be the true length. So join between A dash and B1 dash with a little bit thicker than the XY line. Then as we know that the distance between the end projectors is 50. So from end projector A you measure 50 mm horizontally and you draw a vertical projector so that it will going to cut the locus of B here, and you mark this point as B dash and then join A dash B dash with a dark line. So now we need to find out the top view, so you have to take the true length in the front view. So you may, since you know that it is a true length in the front view, obviously that line should be parallel to XY line in the top view. So that means when you project this line till to the locus of A, now what happens? AB1 is the line which will going to be the parallel to VP. Since it is parallel to VP, so you are getting the true length in VP. So with A center taking the radius of AB1, you draw a arc such that it will going to cut this end projector here. So you mark this point as small b, then you are going to get the locus of B. So now we will going to get the true length here. The true length is 90 mm. So now similarly we want to find it from the other direction. That means I want to find out the true length in HP, true length in the HP. So to find the true length in the HP, so what you need, you have to take the front view line and you make it parallel. So obviously in space when you are rotating it, you are going to get this parallel to HP. So you are getting the true length in HP. So that is what we are doing here. So you take, once you got the front view, you draw a arc so that both A dash and B2 dash is above HP by 10 mm. So obviously that line will going to be parallel to HP. Once you are getting the parallel to HP, so you are getting the true length in HP. So from B2 dash you draw a vertical projector such that it will going to cut the locus of B in the top view. So you mark this point as small b2, then you join AB2 with a little bit thicker than the XY line, and since it is parallel to HP, so you mark this as the true length, which will be capital A and capital B. So and identify the angle phi So that phi will be equal to 42 degrees when you are doing it in manual. When you are doing it in computer, it will be 41.63. So this is how you will be able to analyze this problem in 3D and also in the stepwise. But how to solve this? By using sketchbook. So first what you have to do is first you draw the XY line and you mark VP and HB as shown. Then from XY line you measure 10 mm and draw a horizontal line above XY line. And similarly from XY line you measure 15 mm below XY line and you draw a horizontal line. Consider any point on these two horizontal lines and draw a perpendicular, so that you will going to get a dash, small a dash, and a dash in the front view and small a in the top view, and also capital A and capital A in brackets. Once you get this, now we need to identify the locus of B. NB is 55 mm above HB. So from XY line you measure 55 mm and draw a horizontal dash dot line. So this will going to be the locus of B, and you mark this as locus of B in the front view. So with A dash is center, by using the protractor you measure an angle of 30 degrees because the line is inclined at 30 degrees to HB. So draw a horizontal, draw an inclined line at 30 degrees such that it will going to cut the locus of B in the front view here. So you mark this point as B1 dash. Since it is the true length, so you mark this as capital B and capital A. Then we know that the distance between the end projectors is 50 mm. So from the projector A, you measure a 50 mm parallel to XY line and draw a vertical projector both in the front view and as well as in the top view. In the front view, since you have the locus, it will going to cut it here. And you mark this point as B dash and then join A dash B dash with a dark line. But in the top view, it is still extended because we don't have the locus in the top view. Now we need to find out the locus in the top view. So to find out the locus in the top view, so first we have to take the, because since we know this as the A dash B dash, so once you join A dash B dash with a dark line, the top view of the point B should lie on this vertical line because B dash is here. But we have the front view true length. Since this line is the front view true length, obviously that line should be parallel to the XY line in the top view. So when you are projecting B1 dash here, A is in front of VP by 15 mm. So B1 should also be in front of VP by 15 mm. So you draw a vertical projector from here to the locus of A in the top view. So you're going to mark this point as B1. So what happens? Both A and B1 is in front of VP by 15 mm. So now the top view is here, but actually the top view should lie on this particular end projector. So with A as center, taking the radius of AB1 by using the compass, you draw an arc such that it will going to cut the locus of B in the end projector to get the point B, the top view, on this end projector line. And you mark this point as B, and through this point B, draw a horizontal dash dot line, which will going to be the locus of B, and you mark this as the locus of B. So join A to B with a dark line. Now we need to consider the front view, top view true length. So to do that, first we are going to take the front view and make it parallel. So with A dash as center, taking the radius of A dash B dash, you draw an arc such that both A dash and B2 dash will be above HP by 20 mm. And from B2 dash, you mark this point as B2 dash, and then from B2 dash you draw a vertical projector so that it will going to cut the locus of B in the top view. So you mark this point as small B2, then join A and B2 with little bit thicker than the XY line, and you mark, as we know that this line is parallel to HP, so you are getting the true length. So you mark this point as capital B. So now you identify the angle this as phi and this distance, and now we need to find out the true length. You take the true length here. So by using the scale, you measure the length from A dash to B1 dash, which will be true length, which will be equal to 90.00 mm when you're doing it in computer. When you're doing it in manual, it will be true length, which will be equal to 90. By using the protractor from A with respect to the horizontal, you measure this angle phi, which will be equal to 42 degrees when you are doing it in manual. When you are doing it in computer, it will going to be 41.63. So this is how we will be able to solve the problem. Both you can analyze and also solve the problem by using the sketchbook. Thank you.